In example 2, we're going to solve several systems of 3 equations, 3 unknowns, using the RREF function in our graphing calculators. Okay, so in part A, we have the following system. 9x plus 5y minus 6z equals 102, okay, so forth and so on. You can read it there on the screen. And I'm going to solve this using RREF. So the very first thing I need to do is put it into an augmented matrix. So the augmented matrix would look like this. The first row would be 9, 5, minus 6. Then I have the bar, 1, 0, 2. And then on 4, 5, minus 10, 85. Minus 5, 7, 3, 32. Now, generally speaking, I would need to do row operations to put this into RREF form, or in other words, to put it into a terminal matrix. We are going to see how to do that later, how to actually do the row operations by hand. But for now, while we're still getting kind of warmed up on this sort of problem, we're just going to plug everything into the calculator and let it do the row operations for us. So if I enter that into the calculator, and remember there are instructions in the notes for how to enter these matrices into the calculator, and then I use the RREF function. This is going to give me 1, 0, 0 as the first column, 0, 1, 0, 0, 0, 1, and then the last column is 5, 9, minus 2. So this is the ideal situation where I get a unique solution, which I can just read off from the terminal matrix. So my solution here is x equals 5, y equals 9, and z equals minus 2. Okay. Moving on to part B, same idea. Step 1, I put this into step 1, I put it into a augmented matrix. So the first row is 2, minus 5, minus 11, minus 57. The second row is minus 3, 6, 15, 72. Remember, I'm just reading the coefficients off here. Then minus 1, 2, 5, 24. So I have here a 3 by 4 matrix. I enter that into the calculator, and then I ask it to put that matrix into RREF form, and what I get back out will look like this. So looking at this bottom row, I can see that this is a dependent system. The two equations that I have looking at the terminal matrix are x minus 3y equals minus 6, and let me fix that. That's x minus 3z equals minus 6, and then y plus z equals 9. So my answer here is going to be that the system is dependent with the general solution given by, I'm going to solve for x and y, and I get that x is equal to minus 6 plus 3z, and y is equal to 9 minus z. Okay, so this is the solution to part B. In part C, just like before, I start by putting the system into an augmented matrix. So going column by column, I get 6, 4, 2, 7, minus 6, 13, 5 minus 4, 9. After you enter this into the calculator, always double check and make sure that you entered it correctly, that you didn't make a sign error or anything like that when you're inputting the matrix. But if I enter this matrix in and then put it into RREF form, I actually get something like this. 1, 0, 0 is the first column, 0, 1, 0 is the second column, and then I get these decimal entries. 0.0 3125, 0.68750, and then the last column is 001. So, if I don't want to work with these decimal numbers, there is a way to get the calculator to give you the answer as a fraction. Basically, you hit the math button, and then the very first option under the math menu is to convert to fraction. However, I don't really need to mess with that for this problem, because if I look at the very last row, I see that this is an inconsistent system and that there is actually no solution. So I simply write inconsistent no solution. There is no combination of values, x, y, and z, that would satisfy this system. Okay, so moving on to the last piece, part D. I put this into an augmented matrix, minus 1, 3, minus 1, minus 2, 3, minus 1, and 4 minus 9, 3, and then the last column is minus 7, 12, minus 4. Now I use the RREF function in the calculator, and that gives me back 1, 0, 0 is the first column, 0, 1, 0, that's the second column, minus 2, minus 1, 0 for the third column, and the last column is 1, 3, 0. This is another dependent system. So I need the general solution. Reading off the two equations that I have, I see that I get x minus 2z equals 1, and y minus z equals 3. So I'll simplify that in a second, put it in a slightly different form, but at any rate, my system is going to be dependent with a general solution given by x equals 1 plus 2z, y equals 3 plus z. Okay, that wraps up example 2.